Hey YouTube, this is my second recording of this video because I went over the time limit. Sorry I haven't made a video sooner, but I've been a little bit ill. So this is a response to my "The Mind is Not a Computer" video. I'm going to analyze the arguments that I made in the other video and also make further arguments. Okay, so my three main premises for "The Mind is a Computer" argument are that we're living in a monistic world, that is, that there's one type of thing, not two or any more of types of stuff in the universe. Existence is one thing. Second premise, that there are certain laws of behavior applicable to this type of existence, which humans, limited as we are, may be able to understand some of the fundamental principles thereof. Three, consciousness is a process. It's not a thing, and it's not somehow separate from the functioning of the material world. Okay, so they're my three main premises from which I'm going to argue that the mind can be considered as computational. Now, I know I pointed out that the Turing machine was very limited in the fact that it only had 3 operations. This is true. However, from those 3 operations, this is what makes the computer so powerful, is that it can carry out any process which is algorithmically computational. That is, any calculation that you could put to it, which indeed can be calculated and doesn't hold or various other specific problems, it can actually achieve. Now from this very simple rule set, we get meta rules of addition, subtraction, multiplication, division, square roots, irrational numbers. We have so much from that, even very complex decimal number systems, and anything that you'd like to specify that can be calculated can be done on a Turing machine. Okay, so the brain certainly is a complex thing, and I would say that the behavior of the brain is what gives rise to experience, hence premise 3. Now, although yes, there are different types of neurons, the way that many people see the computer as is simply a rule-based system. If this, then do this. Now, this is an argument I've gone into before, but what's really great about computers now, or modern emerging AI techniques, is that they rely on the very principle of emergence. They have the ability to generalize, to recognize ambiguity, and other such features. Now, there's neural networks are often employed, which give rise to this emergent phenomenon. And because of the nature of the Turing machine, anything can be replicated on it. So a neural network, which is a distributed network of particular perceptrons, can be replicated on a computer. Now, I understand the criticism that a neuron is far more complex than what we use in AI, which is a single perceptron to represent that. But I'd argue that that doesn't specifically matter as long as the functional organization is the same and it gives rise to the same responses. The reason being that neurology is quite heavily focused on this idea called degeneracy, that there are more than one particular neuronal firing group which may give rise to the same response. So the same as a computer, you could have different systems running the same program, and in this way the computer mind metaphor rejoins again here. Now, because the computer isn't exactly the same as when it was first manufactured. It's the particular software running on top of the hardwired applications that gives rise to the complexity. Now, in the same way that a computer scientist wouldn't try to analyze a particular program by looking at the CPU and RAM usage, we can't, it's reducible to those particular functions, but we can't necessarily understand it through those functions. In that way, when we're looking at consciousness, although yes, the neurons and the interactions between them are fundamentally responsible for the operations of the human being and then consciousness, we can't necessarily understand consciousness by reducing it down to that. It's simply far too complicated. And furthermore, the particular hardware, if you like, can be changed and is influenced by quite heavily the particular software, the connections, and the patterns that run on top of it. So just as software is a pattern that tells the hardware how to behave, there's an interplay between the hardwired neuronal components of the human brain and the cultural influences, which indeed change these hardwired components without actually being detached from them. So that's one point to make. Now, there's also the concept of parallelity. Now, obviously, computers have just a CPU, and they're not very parallel. Now, I have just mentioned that computers can, of course, solve everything that is computable, so it doesn't matter whether it's distributed or not. It can still perform the same calculations. However, I want to say also that the complexities to do with time, the particular bottlenecking features in a single processing unit, may make it unfeasible to try and come up with a solution to the human brain, if that's what we believe is a major component in consciousness. They may make it unfeasible to program a human brain on a computer. So much work is now also being done, not for this specific reason, but much work is being done in the area of distributed programming. And in this way, it's very similar to the development of a human brain. If you look into IBM's Blue Brain project, you'll see a lot of work that's being done there. So, just to conclude, if we think that consciousness is a process, a material process that happens within this world, and we think that we can attain certain knowledge about how this world behaves, then in replicating that particular process with the knowledge that we can gain from how this world operates, we can replicate some of the features of this world. That's essentially my argument. Now, we can't always get it perfect, but again, to do with degeneracy, I don't think it specifically matters what particular function it's carrying out, because some functions can give rise to the same patterns of responses. So that's an important point. Now, two further criticisms which I want to address before I conclude. Firstly, it's the specific biological and chemical parts that give rise to consciousness. Now, all I'd say is it's the functional components that give rise to it. If we can replicate those, then indeed we can replicate the consciousness itself. However, if this is not the case, then I don't think this is too damaging either, because much work is being done on, like Kevin Warwick and other, I think at the University of Reading, they've used neurons of rats to control particular motor activation patterns, and Kevin Warwick's also integrated technology into himself, so they're combining digital and biological systems in that way, so perhaps that problem can be overcome. The second criticism that I can see coming to this is the quantum criticism. Now, forgoing the particular arguments that I've made about quantum consciousness, if indeed a quantum mechanical principle is needed for the same functioning of consciousness, then quantum computers are just on the horizon. I don't think that's necessary, but if it is indeed the case, then we are beginning to be able to replicate these. So finally, just to conclude, I would say that if consciousness is a process, it's one that can be replicated if indeed we can gain particular laws about this monistic perspective. So yeah, that's my argument. Hope you liked it. I'll try to go into a little bit more detail because there's a lot more that I can touch on. Peace guys, in a bit.